This question is from GATE 2017 Mechanical Engineering paper, set 2, question number 38. The rod PQ of length L equal to under root 2 meter and uniformly distributed mass of M equal to 10 kg is released from rest at the position shown in the figure. The ends slide along the frictionless faces OP and OQ. Assume acceleration due to gravity g to be 10 meter per second square. The mass moment of inertia of the rod about its center of mass and an axis perpendicular to the plane of the figure is ml square by 12. At this instant, the magnitude of angular acceleration in radian per second square of the rod is dash. Let's find out. Now at the given instant, the rotation that the rod is undergoing is because of its own weight, which is acting downwards, which can be given as capital M into g, because capital M is given to be the mass of the rod and g is the acceleration due to gravity. The moment that is causing the rotation will be this mg into this much distance. If we take this center of the rod to be r, then this distance can be calculated as qr into cos theta. So qr is nothing but L by 2 into cos theta. So the moment that's causing the rotation is mg into L by 2 cos theta. For equilibrium, at this instant, the moment that is causing the rotation should be equal to the inertial capacity of the rod, and that will be calculated using mass moment of inertia of the rod, not about its own center, about the point about which the rotation is taking place. So rotation is actually happening about a point which will be the instantaneous center. Let's name it C, and therefore mass moment of inertia will also be calculated about C. So mass moment of inertia of the rod about C into its angular acceleration alpha. So for equilibrium, we can write this equation, and by rearranging this, we can find out alpha. So alpha will be simply mgl cos theta upon 2 into I about point C. M is given to us, G we know, L is root 2, and theta also we know, that is 45 degree. The only job is to find out mass moment of inertia about C. Now mass moment of inertia about R is given, that is about its own center of mass. R is nothing but the center of mass of this rod. So this is given as ml square by 12. Now we can calculate I about C by using the parallel axis theorem. So ml square by 12 plus its mass into distance of the center of mass from the instantaneous center. So that distance will be this distance CR whole square. Now we need to find out CR. This we know that CP will be parallel to OQ and QC will be parallel to OP, because CP and CQ are respectively making 90 degree angles with the surfaces. For C to be an instantaneous center, we need to draw these perpendiculars, and the point at where the perpendiculars meet is the instantaneous center. So this distance CR can be simply found out as half of OC. CR will be half of OC, because OQCP is a square and R is the intersection of the diagonals. Therefore, CR will be half of the diagonal length OC. PQ is one of the diagonals root 2. OC is the other diagonal. So that will also be root 2. So CR is nothing but root 2 by 2. For the time being, we'll write it as L by 2. So we have I about C is equal to ml square by 12 plus m into L by 2 whole square. Adding these, we get it as ml square by 3. Now putting the value of mass moment of inertia about the instantaneous center over here, we have alpha as mg into L cos theta upon 2 into ml square by 3. Reducing the fraction, m by m gives us 1, L by L gives us 1. So we are remained with 3 into g cos theta upon 2L. So putting the values, we will get the final answer for alpha as alpha equal to 3 into g is given to be 10 meter per second square into cos 45. So cos 45 is 1 by root 2 upon 2 into L is root 2. This is nothing but 30 by 4, which is 7.5. And we are finding angular acceleration. So the unit will be radians per second square. Let's go back and fill in the answer. The magnitude of angular acceleration in radian per second square of the rod is 7.5. The concept of this question is from the topic kinetics. To learn kinetics in detail, you can refer to the NPTEL video lecture 32 kinetics 1. It's from the course Engineering Mechanics. The course is by Professor K. Ramesh. He is from Department of Applied Mechanics of IIT Madras. I hope this solution will help you clear your doubt. Thank you.